SpaceX launched over 1,443 satellites into orbit for the Starlink network, and self-guided missiles roared over the skies on the border between the Gaza Strip and Israel. Formula One cars raced around the track at high speeds at the Spanish Grand Prix. What do all of these events have in common? All of them use vector calculus to ensure success. What is a vector? You've probably heard that a vector is an object with a magnitude and a direction, but what does that really mean? To understand a vector, one must first understand a scalar quantity. This term might sound daunting. It did to me when I first heard it. But scalars are actually really simple. Most of the numbers you've been working with within your math career have been scalars, an unmoving value that tells you nothing about the general trend of said value. Almost any number is a scalar. Volume, density, speed, energy, mass, and time are all scalars. Conversely, a vector only gives you information about how the object is moving. A vector is simply a magnitude and a direction. Well, let's think of it in terms of a rocket. A rocket is traveling at 0 meters per second when it is on the ground. This is a scalar quantity. But what this doesn't tell you is that the rocket has actually just fired its boosters and has now begun traveling with this vector and is actually accelerating at 10 meters per second squared at an 89-degree angle relative to the ground. Rockets have to expend more energy getting to geostationary orbit than low Earth orbit. As geostationary orbit is over 20,000 kilometers above low Earth orbit, it takes a lot more work to get there. And you wouldn't want to spend billions of dollars launching a rocket only to have it run out of fuel a couple thousand kilometers away from your target orbit. This is why it is essential for physicists to understand the concept of work. If only there was a way to calculate work given a force. Oh wait, there is! Physicists use a plethora of techniques to model this force, from 3D modeling to Hooke's law. And this is where calculus really shines, because once they know the forces that act on an object, integration can be used to sum up the force at every point. The beauty of this is that it is the work. That's right, the integral of the force is the work. Now, let's get back to that multi-million-dollar satellite you were trying to launch to take over the world. After calculating the force, you integrate it, and now you know the work necessary to get that rocket into orbit before the United Nations shoots it down. Now, you don't need to use calculus when vectors are stationary, but when vectors are changing, integration is essential for accurate calculations. Changing forces on a rocket that can be accurately modeled by vector calculus include air resistance and thrust. Whether you want to use rockets to take over the world or launch a massive satellite network to provide high-speed internet to rural areas, vector calculus is essential for success. Thank you.